Assalamualaikum warahmatullahi wabarakatuh, and good morning to everybody. Today we will learn the last chapter in our course fluid mechanics. What we will learn in this chapter is a pipe flow. This chapter is very important because it's quite very difficult if you didn't pay any attention to this class. I really hope that you can pay attention. Please see with your eyes, please hear with your ears, please write with your hand, and please think with your mind. So, because in this chapter, I will give you one question. We have one question in final exam in this chapter. So it's very important. If you didn't give any pay attention to this class, I'm very pretty sure that you will not be able to answer the question. In the piping flow, you can see in this picture. These pictures are because I have working about more than 7 years in the industry last time before I joined BMAT as a lecturer. You can see it's a very complex of the pipe flow, because we have learned so far is a very just calculating the volume flow rate in one pipe. So what happens if you see the very complexity of the flow, because in the industry didn't see the pipe, only single pipe. We can see the various pipe, a lot of pipe in the industry. So you need to understand how you want to be calculating, they design the pipe in the industry. Okay, so they have two main objectives in this chapter. So the first one, because we need to analyze the pipe flow for the pipe in series, and then the second one is analyzing the pipe flow for the pipe in parallel. So meaning that in this chapter they have two main topic in the pipe in series and pipe in parallel. So in pipe in series, as you can know, is that we have the two pipe. We have two pipe here. For example, you can see in this slide, they have two pipe. This pipe are connected with the in the series connection. So either we can set the diameter is different, is or equal, it doesn't matter. Also the material of the pipe, also we can equal or the same or a different material. So we are connected these two pipe in a series connection. So meaning that when we have learned last topic, the volume flow rate for the one pipe connected in the series will be equal. So meaning based on the continuity law, the volume flow rate, whatever the flow going inside to the pipe 1 will be equal whatever will going out from the pipe 2. So meaning that in the pipe in series, the main important criteria, the main important characteristic of the pipe in series, you must know, you must understand, you must remember is the flow rate will be equal on each pipe. So for example, we have the pipe 1. Pipe 1 consists of pipe A, the material A, velocity, the velocity A, diameter also depend on the A, the length, and also the friction factor. But the second pipe, for the pipe 2 or pipe B, the characteristic is different a little bit with the pipe A. Pipe B, the velocity also different, the diameter also different, the length also different, the friction factor also different. So but based on our characteristics, the main characteristics for the pipe in series is the flow rate must be equal to the pipe. Okay, as I said, in the industry, we need to analyze, we need to how to say that, we need to simplify this pipe in series. As you can see back from the first slide, we want to analyze, we want to simplify these two different pipe, these two different material, these two different diameter. We want to simplify in one type of diameter, one type of material. We need to simplify as one single pipe. From the two pipe, for example, we need to simplify as a one pipe. So we need to find the equivalent length for the pipe in series. So because of the characteristic of the pipe in series, the total heat loss will be is equal to the heat loss in pipe 1 plus the heat loss in pipe 2. Meaning that you need to find the heat loss, because we have the heat loss in pipe 1. For example, We have also the pipe loss, head loss in pipe 2. When they are connected in series, the total head loss will be, we need to sum up the head loss in pipe A plus the head loss in pipe B. Okay, and then the second formula you need to remember is based on continuity law. Whatever going inside must be whatever equal to whatever going outside. So the volume flow rate is equal between the pipe A and pipe B. So we can, based on this characteristic, we can simplify from the two single pipe connected in the series become one single pipe, and then one single diameter, one single friction factor, and then one equivalent length with the new length with the new diameter. Okay, the last two formula, how I want to determine the diameter, how I want to determine the length. We need to, because when we have the two different pipe, for example, we have the two different pipe with the two different material, we have the two different pipe with the two different diameter, we need to simplify as one new diameter and one new length. So based on the Darcy formula, we are simplified, we derive the formula with the FE. E means the equivalent length, is a new length, the new pipe, L is a new length, D is a new diameter. So the A and B is a pipe A and pipe B. If you have the more than two, just sum up with this same formula. So if let's say the friction factor, let's say we're using the same material for the pipe, but only the different material, a different diameter, different length, but only different, but the material is the same. So if the material is same, the friction factor will be equal. So we can reduce to, because the friction factor equal, so the formula reduce to N over D. So from this formula, we can determine the new length of the pipe in series and the new diameter pipe in series. Okay, last one, how I want to get the head loss for new pipe. So we're using the Darcy formula that we have done last chapter. So using the new friction factor, new length, new velocity, and new diameter, so we can get the new head loss. Okay, that's all for pipe in series. Now pipe in parallel. Pipe in parallel quite very simple. So one, for example, as we have learned last chapter, in a pipe in parallel means that in one pipe split to two, the minimum of the split is a 2. If they have no split, only one connection, so there will be pipe in series. But the pipe in parallel meaning that pipe 1 split to 2 for in this case, and then for the bottom figure is a pipe 1 split to 4. When we see the pipe in series also, the diameter and also the material for each pipe also can be equal, can be same, or can be different, doesn't matter, depending on your design. So we need to simplify this parallel pipe one to the single pipe. But the main characteristic of the pipe in parallel, you must know that the point 1 and point 2 here, the pressure at this point, at point 1, the pressure at this point 2 must be equal, and also the head loss at the point 1 and point 2 must be equal. So meaning that the head loss and pressure is same for the all pipes. Is it parallel? So same thing with in our house, we can see that the main electricity coming from the outside, so the parallel we can share the same amount of the voltage for in your house, because of your electricity is connected by parallel series. So same thing in pipe parallel. So what we have learned, we have know that in parallel pipe the pressure is equal, the heat loss will be equal. So from these two main characteristics, we can simplify the two parallel pipe into the single pipe. Okay, for example, here you can see that the pipe A and pipe B, it changed to the new equivalent pipe, new length, new diameter. We have the two different material or two different diameter, pipe A and pipe B. We are the pipe 1 split to two pipe A and pipe B, then split back to the pipe 2. But we want to simplify from 1 to 2 equal pipe, just one pipe, just one length. Okay, so for the because of this The final one, we need to determine the flow rate. We need to determine the new length and new diameter. Okay, what will be the formula that we need to remember? The heat loss. The heat loss is different because of the characteristic of parallel. The heat loss between pipe A and pipe B must be equal. But in the pipe in series, you need to sum up the heat loss because they connected in series. But a little bit different in parallel. Parallel will be equal. But the flow rate, because the flow rate, why the flow rate in the connected in series is equal, but in the flow rate for the parallel pipe is we need to sum up because the volume of the water entering the pipe 1 is split to 2 for this case. So it's actually the containing of the water, for example the fluid of the water is split to 2, you need to divide it by 2. So for example, so the volume flow rate 1 is equal to volume flow rate in pipe A plus volume flow rate in pipe B. And then the new equivalent length, how to get the new diameter and new length based on this formula. And then also with the friction factor, if you are using the same material, the friction factor will be equal. So the formula reduced to this one. So a little bit different with the pipe in series, this one pipe in parallel. We need to determine based on the formula. Last one, the same formula, using for the heat loss. We need to find when you get the friction factor, when you get the new length, when you get the new diameter and new velocity, you put it in this formula, then you get the heat loss. Okay, before we end our topic today, we have the two examples, example 1 and example 2. Example 1 in pipe in series, example 2 in pipe in parallel. Example 1 pipe in series, you can see here, they have a two pipe, pipe A and pipe B. Pipe A and pipe B, they have a material equal diameter. It's equal pipe. Two steel pipe, two equal material, but a different diameter. 150 mm for the pipe A, 100 mm for the pipe B. So the length of the pipe A is 2 km long, and the length of the pipe B is 1 km long. The water is pumped in 15 degrees C, and then the velocity in the pipe A is 5 meter per second. So with the friction factor for the both pipe, because of the same material, so the friction factor is taken as a 0.02. The dynamic viscosity and density is 15 and 1.09 to power of minus 3 pascal per second, and also the 999 kilogram per meter cube. Okay, we need to find the flow time of the flow regime in each pipe. We need to find the total equivalent length for in terms of pipe A, in terms of the pipe B also, and then we need to find the heat loss. Okay, the second example we will do next is a pipe in parallel. You can see here for the pipe A split into the two pipe B and pipe C, then split back to the pipe D. Also we need to find the equivalent length, we need to find the total system heat loss, we need to find the velocity as well. So this was our topic for today, pipe in parallel, pipe in series. So I just want to recap back what we have learned is we need to change, we need to simplify the pipe in series to new length of the pipe, one single diameter, one single length. Also same the pipe in parallel, we don't want to split. We don't want to split the pipe. We need to change the one single pipe. Okay, that's all for today. So I hope everybody can do both this example, and then we can discuss in class. Okay, see you, thank you, and see you again in the next class. Bye bye. Assalamualaikum warahmatullahi wabarakatuh.